is Dr. C. Sonia, Assistant Professor in Chemistry, SNS College of Technology. Today in this video, we are going to see about the chemistry of analytical techniques. So what is this analytical techniques? It is the scientific studies of the chemicals present in a mixture or a compound. Okay, this analysis, chemical analysis, it can be broadly classified into two types. One is the quantitative and another is the qualitative. What is this quantitative analysis? Quantitative, it refers to the presence of the amount of substance that is present in a compound or a mixture. So we are going to identify how much amount of that particular substance is present in a mixture. What is qualitative analysis? Qualitative analysis is nothing but we are going to identify separately whether a particular compound is present in that mixture or not. Okay, so this qualitative, it refers to the presence of a particular substance or the chemicals that is present in a compound. Okay, what is the analytical techniques? When you go back to this, there are different techniques. That is, they can be broadly classified into one is instrumental and another is conventional. So this instrumental techniques, it can be further divided into spectroscopic, electroanalytical, thermoanalytical and others. Okay, what is the spectroscopic technique? Spectroscopic techniques is you are identifying a presence of a particular compound in a substance or in a mixture by the spectroscopy techniques like ultraviolet visible spectroscopy, infrared spectroscopy, atomic absorption spectroscopy, etc. And next is the electroanalytical techniques. What is this electroanalytical techniques? You are identifying a chemical by using a potentiometric techniques. Then what is this thermoanalytical techniques? That is the identification of a particular substance by DTA, TGA, that is thermal analysis. And others, there are different techniques like X-ray, then SEM, TEM, etc. And next is the conventional method. What we do? Volumetric analysis, which is very familiar. Volumetric analysis, we find the amount of the substance that is present, and in the gravimetric, using the gravimetric method, we find the substance. So on the whole, what is this analytical techniques? It is the scientific separation, identification, then qualitative, quantitative analysis of a particular compound in a mixture. So that tells you the analytical techniques on a whole. We can see about the analytical, the basics of the ultraviolet visible spectroscopy in this video. Ultraviolet visible spectroscopy. So what is this ultraviolet visible spectroscopy? When ultraviolet or visible rays, they pass through a compound containing multiple bonds, there is a transition of electrons from the lower level to the higher energy level, and it gives rise to the ultraviolet visible spectroscopy. So there are different types of transition. What is this transition? That is the electrons. Okay, you will have a, this is a ground state. I am represented by Eg, and this is excited state. I am represented by Ee. So what will happen? The electron that is present in the ground state, you have the H nu, the radiation, it comes and hits the electrons, then it is transmitted to the excited level, Ee. Okay, this is the transition. So there are different types of transition that occurs in the organic compounds. There are 4 different types of transition: sigma, sigma star, n sigma star, pi, pi star, n pi star. So we are going to see what it is actually. To understand this, we are going to see in the energy level diagram. This is the energy level diagram. So this is the molecular orbitals which is got by combining of the atomic orbitals. So sigma, it represents the bonding orbital, bonding molecular orbital, sigma star, anti-bonding molecular orbital. This is pi, pi star. This is n is non-bonding orbitals. Okay. So there will be a transition of electron. That is what the sigma star it represents, the transition from the sigma level, that is the bonding level, to the anti-bonding level. And here this is pi star. It represents the transition of the element from pi to pi star. This is bonding and this is anti-bonding. And here you have N to sigma star. That is non-bonding to sigma star, anti-bonding. Then you have N to pi star. So these are the different types of transition that is possible in this compound, where you have different types of bonding. So we will see where the sigma star transition occurs. Sigma to sigma star transition, it occurs in the compound which is having a single bond. Okay. So when there is a single bond, it is sigma bond. So CH, CC, these types of compounds, organic compounds, they have sigma star transition, and N to sigma star. N refers to the non-bonding. So if you have a heteroatom in a chemical, it will not occur, it will not take place in the bonding process. So heteroatom with the single bond, because it is non-bonding to sigma star. Okay, so C, O, C, N, C, H. In these types of compounds, we can see the N to sigma star transition. And next is pi to pi star transition. So if you have a pi bond, then there should be a double bond. Okay, so double bond, one will be a sigma and another will be a pi. If there is double bond, then pi to pi star transition is possible. That is example C double bond C, C double bond O. Okay, then N to sigma star. This type, that is non-bonding, you should have a heteroatom. To pi star means you should have a double bond. So these examples are C double bond O, C double bond S, N double bond N. These are the different examples. So there is the variation of energy. So the transition of sigma star, it requires a very high energy. Then N to sigma star transition, this requires a higher energy than pi to pi star transition, and which requires a higher energy than N to pi star transition. So sigma to sigma star transition, it requires the very highest energy, and N to pi star transition, it requires the lowest energy.